no. So,
I'm here to enjoy my
okay, the point works, right? But what I don't understand is why are we querying for all of the documents and then grabbing only their IDs and then querying each of the documents individually by their ID? When you already queried for all, so now you're querying twice.
But like querying the second time is just cross-checking your work.
Cross-checking your work. It's programming. You have to cross-check your work. There's no like.
But when you do it the second time, you have
Instead
to
of querying it twice, we could have like some sort of error check. I think that's probably safer because it's 1 point of failure rather than 2.
That's what I'm saying.
You are good at BSing, but none of your shit actually makes sense.
Hey,
I think I'm just gonna start it off with that.
Survive in 3102.
We had ones off at 3102, so I can't actually give a comment on that.
Whoa!
Oh god, bro, spin for me, bro.
There's something called consent is very important.
This is so chop, bro.
what is that? Test?
Alright, 6 of 2. Alright, I think we're gonna start it now, everyone. So make sure to sign in with the QR code if you haven't. So for this workshop, we're gonna have a few things that I'm gonna have y'all download.
You were thinking the same thing.
Y'all. Come on now. Okay, so we're gonna have a few things I need y'all to install while we work on this. So just a bit of an overview. I'm first gonna go over Git and GitHub as a concept. So that is why you use it, as well as some of its features that we'll go on later to start implementing through a test code base that I made. But in order to do that, you will need Git. So you can install Git. I think you can just look it up on Google and you should be able to download it from there. It's quite a simple download, but if you need any assistance with that, make sure to raise your hand and one of our officers will come and help you. You'll also need, so we're gonna go over GitHub Desktop first to go over just the basic implementations of commands. So that's also a download. We're gonna be going over 2 ways to use Git. So I recommend you download GitHub Desktop if you're new to Git, just because it's a great way to learn it, as well as VS Code. That's my IDE of choice, so I'm going to go over a few ways you can use Git with VS Code as well. So there's multiple ways to use it. The most bare bones and recommended way is to use it straight from the terminal, but there's a few ways you can make it easier. So first, leave this up there. So I'll give you about 5 minutes for this, and also just, once again, sign in with the QR code if you haven't already.
You want to post like amazing Git install? Git install. Yeah, I really want to make it.
Oh.
Give me 10 days, what can I do?
Answer, bro.
Okay. Without being too cocky, all right?
I can do moving stars.
There we go. ASCII art, chat.
House is sanity.
I don't know if we can represent that in ASCII code as well.
That doesn't exist. Maybe you're working laptop.
I actually would appreciate that.
Yes.
Probably the firmware, that's what's messing up.
Hey, you need help? I know.
What?
Yeah.
All right. So once again, for those of y'all who just walked in, we're going to be going over Git. But first of all, I'd like to have y'all sign in with the QR code as well as download some of these recommended apps. Git is essentially essential for this, and the other 2 are optional but recommended. So I'd say download them in that order, left to right, top to bottom. All right, so I'm going to start it off with a bit of a question. So for those of y'all, what are some of the ways y'all have done coding projects or have shared code? So this could be for a class project, your own thing. Just what are some ways you usually share code with others? Okay.
Google Docs.
Google Docs. Okay, what else?
I've emailed it one time.
So you send it via email, right? Got it. Okay, so notice these are kind of traditional ways of sharing information amongst each other through Google Docs and that, but what it turns out when it comes to developing applications and sending like your code base, there's a lot of issues that could arise with that. So I'm just going to quickly list off. This might be a bit compact, but I'll go by it one by one. These are some of the things I listed that are just things you should look for in an application that you use to share code with others. So the first thing is called version control. And on a very simple, high level, version control is essentially just like a save file for your project. So it creates a snapshot of your current code base. And what's neat about it is it kind of provides a fallback. So say you're working on a project and you want to add a pretty intense change, you can actually create a save spot, right? And you can add that change. And if that ends up breaking your program, you can always go back to that previous save spot, right? So it's like a checkpoint, in other words. Being able to collaborate without conflict, right? So the thing is, when you're sending it amongst each other with like Google Docs and such, you guys can end up working on like the same file, right? And that can get pretty annoying. And although that could be solved via communication, there's a lot of other ways we can ease that tension, and Git does a lot of that for you. So just having each person manage their own copy of the code base, and they can add their own unique changes to it on their device, and then have a way to like kind of combine it all into one singular code base. That's kind of what's neat about Git. Also being able to just review others' code. So Git also has a lot of GitHub actually has a lot of features around it where you can protect certain copies of the code from things being launched into it. And that kind of leads on to permissions. That's very important, especially once we get to more of a corporate or academic setting where you don't want certain people looking at your code or making changes to it. Or maybe someone with malicious intent creating like malicious code and then like, I guess, merging it onto your main code base, right? Just all of these aspects are things that you want, and that's what Git provides. So a little bit of a story about how Git was created. This is Linus Torvalds. He's a neat nonchalant programmer who just, made two little neat side projects. So this one thing called Git made in about less than a week. And then Linux, which I just call birth control, even though I plan on using it. So yeah, a little bit more about this guy. He is kind of one of the first developers to stand for open source programming, which highly influences the development landscape today. So a lot of the things that you use on your computer, or just a lot of things surrounding you guys, like are open source, so you could thank him for that. He also has quite a bit of a personality here. I'd like to be a nice person and curse less and encourage people to grow rather than telling them they're idiots, but that's just not me. And the last part, I guess, freak and then letter X, that's not really it. Anyways. He's also very passionate when it comes to working with NVIDIA, so we can ask him a bit. Let's check out what his opinions on NVIDIA are.
It's the exception rather than the rule. And I'm also happy to very publicly point out that NVIDIA has been one of the worst trouble spots we have with hardware manufacturing. And that is really sad because NVIDIA tries to sell chips, a lot of chips into the Android market. And NVIDIA has been the single worst company we've ever dealt with. So NVIDIA, fuck you.
So you could thank this man for Git as well. Git, which you'll essentially be using for the rest of your coding career. Of course, Linus Torvalds to go. Nothing, just a bug probably. Okay. So we can go a bit into the features of Git. So the first thing is known as a repository. A repository is essentially just your project or code base. It's like a unit used for that. And usually you'll contain some few things in it, including the code base itself, so all the files. In this one, you can see there's a folder for a Java project and a Python project. This is the code. This is essentially the repository that you guys will be using today to just learn Git as well as a few features around it. So in this case, those two files represent the actual code base, but there's usually a few other things surrounding it. For the scope of the hackathon or like some just basic class projects, you would also maybe want to make a README file. So README is just a markdown document that acts as kind of a manual for the repository. So it just goes over a few things. It goes over what it's for, how to install it, as well as a few things surrounding its development process, like version history, as well as like some future implementations, all that stuff, right? And there's GitHub has a few other features surrounding it. So it has a task board. Task boards become very important as you start working and becoming more experienced in development. It also has like things for automations, which are very nice. We're not going to go over it for the scope of today, as well as scope of a hackathon, but a few things to know for later. Another tip I want to hand out to y'all is to be careful with your repository name, as well as the name of your commits. More on that later, as well as just like the overall code that appears in your main copy of the code, main branch, right? You want to be careful about the naming, especially if you set the repository's access to public, right? Because a lot of other people, including your employers, could end up seeing it. So for example, I just was just going around the web one day, don't ask why, and then I saw a repo like this. Yeah. It does. So yeah, it's a Johnson parser, I guess. And one of the commits says like, what is my life? So just employers could see this. Of course, it was also maintain the honor of Chen Zhang, so F in the chat for him. So a bit more on that. So branches, I was talking about it earlier, but essentially branches are, you can think of it as an instance of a copy of your code, right? So what's neat about Git is you can take your current copy of the code and you can take your current instance of your code and copy it and then add your own changes to it. And then later on, those changes could be merged back into your original, right? And then those changes become applied. So it essentially allows you to do unique things and have a unique workflow. We'll go into the very common practices that I recommend you guys have at a hackathon, because knowing GitHub is one thing, but knowing how to properly use it makes you like 10 times more efficient as a developer. And time is like the essence in hackathons and really in any project in general. So we'll go a bit more into like this graph later on, but essentially what the common standard is to have 3 types of branches. So you have what's known as a main branch, and it's essentially the branch that's released to the public, right? This is the copy of the code that should always work, shouldn't have any bugs. It should be your like it should basically be the final version of it, right? And then what you do is you have a branch stemming from that known as dev, right? It could also be named test. And this is where you make all of your changes, right? And as you make these changes, you'll expect new bugs to pop up or you'll expect new things to happen. So that's why it's important to make a branch separate from main, because main, once again, it's always going to be something that's working, right? Of course, you're a developer. You still need to make changes. That's what dev is for, right? Dev's not really going to be exposed to the public. That's fine. It'll just be exposed to you and the other developers on your team. Now, the thing is, with dev, you're going to create another branch, a third branch, known as a feature branch from dev. So that's what's going on here. We're creating branches from it. And these are where you make your actual changes, right? So say you need to add a feature to like add a new function to a certain file. That's what's going to go on here. And then depending on if it turns out well or not, you're going to merge it back into development. So in this case, it didn't. That's why it ends. But in this case, someone did end up making a change and they merged it back into development. So then after you do that a few times, and once you're ready to finish your project or send out a version to the public, you're going to merge develop into main. And that's kind of how you guys should think about the hackathon. So you're going to start out with like an empty main, and then you're going to have a dev, and then as you guys think up of new features and pages for your app, maybe the backend team decides to make a few JavaScript files, implement like a local database, SQLite, whatever you want to do. They're going to add that to dev. And then let's say what I recommend, there's multiple ways you can go about this, but let's just assume towards the end, like in T-5 hours from the submission, Sunday at like, give or take 6 or 7 a.m., what we're going to do is you're going to try and push dev into main. Which is essentially the process of making sure everything works before sending it out to the public, right? In this case, that'd be the presentation to the judges. Yeah, ignore the formatting here. Trust me, it's the worst slide you'll see today. But yeah, Commits are essentially that process I was talking about earlier of saving a snapshot of your code, right? It's like the saving point. It always should contain a message, and we'll go a bit more into how your messages should look like for commits. But what's neat about them is you can view them, so you can view previous versions of a branch. You can also restore it. So if you don't like what currently exists, you like the previous version, you can go back to it and make that the new thing. You can also continue. What's neat about that, and neat about GitHub in general, is you could work, the repo is online, so you can actually work on any device, right? So I can work on a portion of my project here, and then I can go fly to like Mongolia and then work on it there, right? And then we have the process of merging. I already talked about it a bit, but merging is essentially the process of taking the changes made on one branch and applying it to the other branch so that the other branch will contain all of these changes that were in the initial branch that we were merging it into, right? And there's a few practices you could use. I recommend not putting too many changes at one time into one branch because usually what happens is if you merge too much, you might walk into what's known as a merge conflict. I'll be able to show you all that today and how to handle them, but a merge conflict, you usually don't want to deal with them because that requires you to manually go into the merge and like manually delete things or keep them. And usually most of the time Git's just automatically able to do it. We want that. All right, any questions surrounding some of the Git terminology I just went over? Okay, so once again, you could picture this as for a hackathon or your school project or whatever, but I'm just gonna go over just an example workflow, right? So here we have about an open beta for a game. And usually during an open beta, you release it to the public and the people usually play it and they start reporting bugs that occur, right? So in this instance, we're going to listen to any player feedback that exists in this right here, which is our current state of the game, which we release to the public. And then in 6 months after we listen to people's feedback and we make the changes, we're going to implement them back into our main branch after testing it and everything. And then that's going to be the final release of the game, right? So in this case, obviously we're going to make a test/dev branch, right? And our first developer is going to make changes to an overpowered card, right? It's pretty rare in industry for game devs to listen to the players and nerf overpowered things, but in this case, our developer was the outlier, right? So they're gonna make some nerfs. They're gonna nerf Mega Knight, very OP. They're gonna nerf Bastion, because that also exists in this game. And our developer in this case actually is going to do one thing. She's actually going to end up buffing one of her favorite weapons, right? Obviously, the Git master, that's the person who handles all the branches, the overseer of the whole repository. They're not going to like it, right? So what ends up happening, right, is they're going to deny what we call a pull request. More on that later, but basically, the Git master said, you can't merge this, right? I saw that change. We don't like it. So we're not going to do that. There's another bad practice being done here, actually, which is that they made too many changes at once. If you could see that, because they end up losing all of this progress as well, which could have been valid. So let's look at what developer 2 does instead. So they're going to want to make changes to just the player's movement, right? And the Git master, after testing, ends up liking these changes and decides to accept the pull request, and now it exists in dev, right? And then after that works, we're going to quickly run a few tests on it. That's what this right here is for. They're calling it release. This is just some last minute checks to make sure everything's working, there's no bugs or anything. Because once again, after this, we're releasing it into main, right? And then that's what they do. This is the final release. So that's kind of how your hackathon would work, right? You'll create the dev branch, you'll branch from dev branch, you'll make your individual changes, then you'll merge it back into dev. And then let's say towards the end of the hackathon, you're gonna do some final tests on dev after all those changes over time, and then you're gonna push it, or sorry, you're gonna merge it to main. Main's gonna be the final product, right? Sounds good? Clear on that? Great. And yeah, obviously they're gonna make microtransactions now because the game's good. That's usually what happens, unfortunately. So a bit more into GitHub specifics. I kind of just compiled the bare minimum I think you should know when it comes to a hackathon project or a class project. And that's essentially just knowing how to make a repo on GitHub, as well as invite your teammates, make sure the visibility is good and all that, public or private. Also just like what I'm considering the 5 basic commands for making all of these changes I just talked about, the process of getting it, adding your changes, committing it, and then merging it with another branch, as well as a few safety practices I recommend you guys for certain things that you might encounter in the hackathon. So for starters, we're going to use GitHub Desktop. So once again, who here has GitHub Desktop installed? Let's go with that first. Okay, a few people don't, so I'm gonna give y'all a few minutes to do that. In the meantime, we could do that. Yeah, does the first who have any like? Yeah, does the first who have any questions on? Check out this week. You might be able to get before downloading it. That's the second. That's it. Okay. So while you guys install Gits and GitHub Desktop, we're going to have our first round of games. So once again, let's say the first place, second place, and third place is going to get a debugging rubber ducky. These are really good for developers because whenever you're encountering an issue with your code, it's common practice, or not common practice, but it's a good tip to actually just like talk to them. I know, a bit weird, but it actually works. Talk to them out loud about what you're doing, and it usually helps you debug current issues that you're facing. So I'm going to do that real quick.
Is anybody currently struggling
Where's
to
the time?
install Google Desktop?
Dino, can you connect the desktop to this? Actually, I got it.
That's not.
It's Electron PC, right? Has to be. Okay, it is. Yeah.
The first one.
Okay. All right. So feel free to join. For those of y'all who might be watching the video right now, it's on another screen, so you might want to skip a few minutes, about 5 or 6.
Are you a cool personality?
No. What time is it? Yeah. How's that wrong track? This dude. Alright, I'm gonna start it now, so. Okay. Should I do that? Okay, nice. You know, with the quick draw. Alright. My bad, that bitch, yeah.
Yo.
Okay, so yeah, just reiterating it here. Commit is like a save file, and then the process of merging is where you take one change from a branch and you apply it to another branch. So you like update the branch.
No.
Wow. You should have done some research online, bro. Let's play here. Yeah, so remember. I think I put myself too. Thanks. Alright. You can't get this one wrong, no. I mean, this is like basically a giveaway. I just want to believe the guy said Steve Jobs is trolling. Alright, last question, y'all. I know sometimes it seems like you want to get lazy and do it, but trust me, it'll always end up biting you in the back. Unless you literally have to make like, I don't know, GPT wrapper. Alright. Alright, good job, y'all. So, I guess you just come over here to Dino and he'll help you out with this. James. Damn. You gotta throw it?
You gonna catch it from there? You can pick.
Alright, back to GitHub. So now I assume y'all have this.
Cameraman. You just doing.
I don't have desktop for that. Imagine. I do. Alright, so once again, as we work through GitHub Desktop, if you have any troubles installing it or just working, you're falling behind, there'll be a copy of this presentation posted after this in the Hackathon Discord as well as on our YouTube channel, so feel free to check that out. But you'll also just raise your hand and Mentor will come and help you. So, let's go into it. So I'm just going to quickly go over this work cycle, just reiterate over it. Essentially what you do is you select a repository to work from, right? And what you're going to do is you're going to do is known as pulling. So pulling is just a git command that gets the current copy of it, so it's latest commit from a branch, and it uploads it to your local device, right? So we call that local repository. It's simply just your device's hard drive, right? Then you just make whatever changes you want to it, and then you commit. So commit just means you save whatever changes you made, and that's like the new version of it, the new latest version. And then you could use what's known as push. Push is very similar. It's basically the opposite of pull, since you're basically taking whatever your current commit is, and you're just pushing it to the local, the online repository, right? For your given branch. And then what you do is you'll have dev or whatever branch you pulled from earlier, and then the new branch you made that has all of these changes that you just pushed, and then you're going to merge them together. So now dev contains all of those changes you made. So that's essentially the cycle you want to work with, right? So we're going to emulate that in desktop. They make it very easy to do so. So once again, if you have any hackathon teammates who don't really know Git, instead of pushing them to learn like an hour-long tutorial on Git through the CMD, it might honestly be easier to have them work through GitHub Desktop instead. I know that's what we're going to push for. Overall though, I will talk about this later, Git through the command line is just way better in many ways. So after the hackathon, after you get these training wheels off essentially, I highly recommend you all start using the terminal for it. So a quick way to check if you already have Git installed, so we talked about it earlier, but you will need Git in order to use GitHub Desktop, is you can open your command line and then you can just type git or git-v for version and it should return something. If it says unknown command, you don't have it installed, raise your hand or try and download it, right? So we're going to do that real quick. So just CMD, yep. And obviously mine is working, so that's great. Yeah, what's up?
I had a question about branches before we leave.
Yeah.
Is the Git master the only person that can make new branches?
No, so it depends. You could change the settings, but the best practice is to have anyone able to make a branch from dev, right? And dev is from me, so that's the branch.
So anyone can make a branch.
Yeah, I'd say so. That's the right way to do it. Obviously, that's what it looks like. First of all, I actually showed us at the beginning, but if you haven't made GitHub already, do that. Another piece of advice I want to give out for GitHub is two things. So for your email, you do not want to use your school email because you will be using GitHub after LSU, right? So you want to use a more professional email, whatever your work email is. That's what I recommend. Dana here, don't be like Dana. He uses the school email. After he graduates from LSU in 5 years, he's going to essentially...
I'm graduating this.
Sorry, 5 weeks. He's going to... I don't know. You're going to have to change your email, I guess. That's just going to suck. Also, your username. Make it something not crazy. Because once again, usernames are also something people are going to see.
You're gonna use this professionally.
Fair enough. Actually, sometimes you will. Like open source committing. You also, it's a good thing to put your GitHub profile on your resume. That's like a proof that you've actually been working on things. So, we're going to first of all do what's known as cloning a repository. So, cloning a repository is essentially where you copy an already existing repo online and you copy it onto your local device, right? So, we're going to be using my test one today. So, it's right over here. Let's see. I could just send y'all a link to it, honestly, in the Discord server. Thinking that's the best approach. Otherwise, you should be able to just look up GitHub Workshop Fall 25 in the search bar up here, and hopefully it should appear, unless someone else has like a very identical name, which that might be the case actually. Who knows? It'll basically have this username though. It'll be in the Google Developer Student Club organization. That's how you'll be able to tell. But I'm going to upload this in resources. Okay, so it should be in resources. You can access that repo. Just make sure you have the link copied, right? Because we're going to need it. Or actually, yeah. So access the link. You should be on this page right over here. This is essentially what a repo looks like, right? We got our branches here. You can click on this. You can see all your branches. I already made a main and a dev. You can add your own branch. You can also view the code base here as well as view your previous commits. So these are the previous commits I made along with their messages. As you can see, I'm good at making commit messages. And then you have the README. So what's neat about READMEs is GitHub automatically displays it on the bottom here. And because it's markdown, you can make it look all fancy and stuff. Some of the things they'll usually contain are project structure. So if your project's larger, you can kind of display your project like so. And you could like have comments next to each displaying what they do. You can also have, it's important to also have installation instructions. This is also very important. Ours is very simple. You simply just run a single script in Python or Java, right? So yeah, but obviously as your projects get more complex, you'd want to mention it here. You'd also want to mention all the dependencies and maybe send a link to them. So if you're using something that has to use, what was the name of that C++ framework for graphics? Like OpenCV? So let's say there's like a dependency you got to download for OpenGL. Then yeah, you just link it there and you tell them to download it, right?
What is OpenGL?
And this is also just a few other things you can add, like example ideas for people to add, as well as contributing guidelines. We'll go over this towards the end when it comes to contributing to open source projects. But yeah. For the sake of the hackathon, I don't think you should spend too much time on your README. And also a lot of the time, people, myself included, use ChatGPT for this because it's pretty good at it if you give it the right info. But obviously, you don't want to solely rely on it. That's a good general piece of advice. You never want to solely rely on ChatGPT 100% for something. You want to use it to help you out when structuring things and such. So yeah, our project's pretty simple here. I'm going to go over it a bit in detail. So I essentially just have a very simple project containing of two files. We have calculator file, which essentially just calls functions from another file and it prints it to the terminal. So you just give it parameters for A and B, and then it just prints all of these operations. And then we have another file called operations. This is where we'll be making some of our changes, and we're just going to be adding new operations to it, right? So it already has the basic for adding, dividing, subtracting, multiplying, but let's say we want to add something like modules, right? This is kind of what we'll be doing. So I'm going to have y'all do what's known as a fork. So if you see here on the top right, there'll be a button called fork. Essentially what a fork is it saves this copy of a repo into your own. So you basically download it and make it your own project, right? So I'm gonna go do that real quick. You can give it whatever name and description. You can also keep it. Make sure copy the main branch only is activated, or maybe, yeah, let's have it activated. That's fine. Okay, so now we should have our own copy. It should say something like this at the top. Now we're going to try and clone it. So how do you clone a repo? Well, you're essentially just going to take the URL of it. So I'm using the app, but I'd copy it from here, but you'd obviously copy it from the top bar. And then you'll go over to GitHub Desktop, and you'll head over up here, right? So you might have to link your GitHub account first to GitHub Desktop. And once you sign in, it'll sync your GitHub account. Essentially what you'll do is you'll press add right over here, and you'll press clone, and then select the URL, and you'll just copy and paste it, right? Once again, just raise your hand if you're falling behind on a certain spot. Okay, so we're just going to clone this, and we'll just do that. Okay, so once you clone it, GitHub Desktop will give you a few options to actually open it in your own IDE. So in my case, it's VS Code. This is kind of one of the weaknesses of GitHub Desktop, in my opinion. I don't think it works with any other IDEs. You can correct me if that's not the case, but in our case, we're going to open it with VS Code. Once again, if you're falling behind on GitHub Desktop, that's totally fine. We're going to go over how to use Git from the terminal after this. And that's like a whole other way to do it. Okay, so you can use it with other IDEs. That does make sense. Okay.
Just not with them.
Well, that's fair, to be honest. Okay, so this is our project. It basically took whatever was a main and it copied it into our own local repo. So okay, so a few things about VS Code specifically. On the bottom left here, you'll be able to see your current branch, and if you click on it, it'll actually display all of your branches as well as give you a few features to create branches. You can also do it on GitHub Desktop, which is what we'll be doing here. So you click on the top here, and then you can just simply add a new branch. We're going to name ours dev. Pretty simple. Then it should give you an option to publish it. Essentially, publish means you're actually just like, it's very similar to push where you're uploading it online, but because the branch hasn't existed, we just created it. You're actually just creating it as well online, so that's what we're going to do. Should contain everything, I hope so. Yeah. Okay, so once again, this is our dev branch. So we're going to create another branch from dev and then add our changes to that, right? So once again, we're going to do this. And let's name it something like add modules, right? And this feature right over here, when you add another branch, it's going to give you a few options from which branch to, basically which branches it's like origin. So you're creating a copy of it, what's its like original copy coming from. We're going to choose dev, not main, because once again, that's what we're merging into later on. Let's do that. Same thing as usual, publish it. Okay, great. So now that we have that all synced up, we're going to begin making our changes. I'm going to make it very simple. Your changes could be in either of these. So if you're more familiar with Java, you would just make your changes in these files. Otherwise, we're going to use Python though. So let's make something real quick. Dude, my PC is fried. That is insane. Okay, so it's going to be very similar to divide, in all honesty. Just do it that way now. Okay, so modulus essentially is just like division, except it returns a remainder instead of the actual product. So obviously this rule right over here is still going to apply to us. So yeah, if b is equal to 0, we return, that'd be mod. Otherwise, we return that right over there. Okay. So obviously you can implement whatever you want. That's what I'm choosing to implement. So if you're on VS Code, actually what's neat about it is you might get this right over here. This just indicates that you added something. If it doesn't, what you should do is install an extension for Git. So if you're on VS Code, you'll also need to install an extension for Git. I think if you just look up Git over here in extensions, it should show up. Yeah, so the Git extension pack, you just want to install that. It just contains a bunch of tools to make your VS Code or IDE a lot more usable for Git, and that includes highlighting changes. You can also just add, you can make commits, and you can do all that. We'll go into that later, but for now, let's just install that. Okay, we're also going to add the ability to use it inside of our calculator file, so let's do that real quick. Let's need one. Now if we run it, it should work. Great. Okay, so we just made those two changes in those two files, right? Those are the additions we made. Obviously for the hackathon, your changes might vary. Sometimes you might add new files altogether. You might also add whole objects. You might add pictures in your assets folder, a page in your React or HTML, whatever. But as we make these changes, they'll actually appear in our GitHub desktop application, right? So a bit more about that is, this is known as the staging area, right? We'll go a bit more into the staging area later on, but on a high level basic overview of the staging area is you have your local repository and you have what you end up committing. The staging area is kind of in between that. So it's a space where you prepare all of your changes that you made, right? And they're just there for display right before you commit them. So anything in your staging area, when you commit, it essentially is like the newer version of that code, right? The reason there is a staging area is sometimes some of the changes you made you don't want in the staging area, and we'll go over that, but in GitHub Desktop, this kind of is an overview. So whatever's in red is a deletion, and green is an addition. As well as you can see all your files here. Green means you added something new. Yellow obviously means you changed it. In our case, we have these additions that we made. That's great. But if you notice, we're going to have this file right over here, right? Now, what we don't want is this is going to end up being in the repo if we commit. And that's something specific to our VS Code, right? The file literally is VS Code/settings, right? That's like specific to our device. So things like this will occur where you have specific files that apply to your local repository that you don't want uploaded online, right? So it can be something like configuration files, but we can also have a situation where we end up having an environment variable, right? And an environment variable is something you use for APIs that might cost you money, like OpenAI or Firebase, just to name a few that you might use for hackathons. And with API keys, you never want to just put the key straight into your repo, right? So you never want to do this. Where like that's not a good way to say it. You never want to copy and paste it here, because the thing is, once you upload it online, a lot of people, they actually have web scrapers that look for API keys and then they use it for themselves, and that ends up charging you, right? So instead, what you want to do is you want to put it in what's called an environment variable, and you would essentially create a file. We'll name it .env, and this is where you'll contain it, right? So that we can't go over right now, but you would also have to, you would basically use a certain Python library known as .env, and then you would load your environment variable through there. So that way you don't have the actual value of it in your code base. Instead, you just have the name of the variable, and then the value for it will be in this file that the user will have to make on their own, right? So that's just a neat little piece of advice for the hackathon. But essentially, if you notice, the problem here is now our environment variable files also appearing in Git. So when we make that commit, it'll be uploaded online, right? So obviously, there's a few things that we do not want being posted online. So the question is, how do we tell Git, hey, I don't want these changes to be posted online. I want this out of my staging area, right? Well, there's one way you could do it, and that is to just remove it from the staging area manually. So in GitHub Desktop, you right-click it, and then you press Discard Changes. But that isn't a good solution because what happens is it'll eventually pop up again when you make changes, right? So you'll have to always manually delete it. So there's another way you can work around this, and that's through a specific type of file known as gitignore, right? And this file essentially just tells Git, hey, all of these files, don't put them into the staging area, but still keep them in my local repository, right? So in our case, we're going to do .ps code. We're going to do .env. Simple as that, right? And now it should pick up on that. Didn't pick up on you though. Or it did, yeah. So yeah, if you notice they're no longer here, that's great. So I'll leave it up for you. Okay, so now the actual commands for uploading it online and committing are as follows. So you'll be able to see your current branch, and you'll also be able to pull. So I was talking about it earlier, but that's like you get the latest commit for the branch you're currently on. It automatically did it for us earlier, so we don't have to worry about it. But you can also do it through this command up here that has pull. But yeah, once we have all of our stages ready, once we have all of these nice changes, we're ready to commit it, then we'll do it down here. So this is where you make your commit. You basically provide your message down here, and then you press commit, right? So you can add whatever you want to the commit message, right? But I recommend that you don't, because you'll end up regretting it later on when you have to look through commits and you're just given blurb and blurb of random text you made. So the question is there a standard towards making good commit messages? And the answer is yes. So I'm going to drop some ball knowledge on y'all known as conventional commits. This is a website that contains a bunch of standards that you should follow for making commits. To make it very simple, these two are a good example. You have for features, and then you provide the title as to what it is at the top, and then you provide a body for for basically a description on the specific changes you made on the bottom. And then you can also do that for a few other things. So you can also do it for fixes you made to certain files. So in this case, we fixed the file known as display, whatever it does, and then we basically corrected a rounding error made whenever you divide floats, right? And then you provide the body. So you can actually view a lot more of these features in this website right over there. Conventional commits, you can also look it up on Google, but it's little things like this that will make you stand out as a more experienced developer. Because a lot of people who use Git don't know about conventional commits. I mean, raise your hand if you heard about this, heard about conventional commits, or heard about some sort of standard to making commit messages before this, right? Exactly, right? Just like Quentin, right? And I think I literally heard about it from Quentin, so there you go, right? So I just want to spread the word out there that we should be doing this, right?
Thank you.
Of course, thank you. Hand over props for Quentin, bro. So yeah, we're going to make the commit real quick, and I'm literally not going to follow my advice and say, no, I'm just kidding. Okay. So just like that, and once you hit commit, it does it for you, which is very nice. So the question is, after commits, you could push it, and pushing essentially is where it's essentially not uploaded online yet. That's what the push is for. The push actually does it. And GitHub Desktop gives you the command right for it. If it doesn't appear there, once again, you can click on repository and it'll appear right over there. So our case, very simple and easy. Yeah.
pull and fetch the same thing?
Okay, so it's a good thing you asked that. So pull and fetch are different. What fetch does is it just takes all of the files from the current commit and it puts it into your local repository. That can get messy, right? So what pull does is it does the exact same thing, except it doesn't just like take it from the branch's latest commit into yours, it merges it, right? And because of the merging process, it makes your code look a lot more organized. So I kind of don't like why it says fetch there. I think pull is better in most cases, so you can do it there if you're using GitHub Desktop, right? So in our case, we're just going to push it.
Question.
Yeah.
So would the fetch create like 2 copies of the same file?
I never use fetch, so I honestly do not know. That's, yeah, once again, pull, there's a reason.
For fetch, for this one, I think it's just checking whether there's a pull request, there's a pull request. It's just checking whether like the current thing is up to date.
Is fetch origin actually like the fetch command, or is it just like a naming conflict?
No, if someone committed, and then like, because it doesn't check the GitHub every time, right? So when you click fetch, it checks whether like someone is committed or not.
Okay, but yeah.
You can't pull it.
Apart from GitHub Desktop, I never find myself using fetch. I always use pull, and I think there's a good reason for that. There might be a few use cases though, so it's a good thing you asked that. Because sometimes, I guess a good instance is if you're in a situation where you're just pulling and you're not getting the right file from one branch that you're pulling from, that's probably a good idea to use fetch, because I think fetch is more of like a, kind of like force it into your repo type of thing, right?
I think fetch is only.
No, it's an actual command. Seriously. Okay, so yeah, we pushed it, and now if we go over to our repo, it kind of tells you it, but I have to refresh my page for this. There we go, right? These are our changes, great. So now what we're going to do is we're going to do what's known as merging. So merging, once again, is that process of taking your changes and putting it from one branch to another. Now, you could merge by using the git command merge, but it's better practice to do what's known as a pull request. A pull request is basically where you make a request to merge one branch to another. And usually I'll just show you all it. So in our case, you can do it right here in the button, but we're going to go over to pull request instead and do it. So new pull request. This is going to appear because we forked it. In our case, we don't want to put it into the original repo, so that's good. We're going to take this branch, which is what we just pushed, and we're going to merge it into dev. Yes, okay. So yeah, GitHub just lists you all these changes. Looks good. We added that, and we replaced this with this. Yep. Great. You can add a title and description. For the sake of time, I'm not going to do it, but this is essentially just going to be a summarized version of all of your commits. So honestly, what I do is if I have a lot of commits, I put all of them into ChatGPT and I say summarize it into a description, and it does it pretty well, and then you use that. So yeah, you yourself can actually accept the pull request and do the merge process, but if you're working on a multi-person project, it's usually not a bad idea to have someone else who's more experienced on the project and what you're working with be what's known as the Git master, right? And this person essentially oversees the PRs and makes sure everything's looking good and then decides to do it. So it's just like another person to look at it, right? So in our case, we're just going to be at confirm merge, and it does it for us, right? Gives you an option to delete a branch. Honestly, you have infinite space on GitHub, I think, so you don't really need to do this, at least for the scope that we're talking about. And now dev should contain all of those changes, right? I'm not in the right branch, am I? They've accidentally done that. It's not good. Okay, yeah, there we go. So now it has everything. The git ignore file, and if we go to Python project, dev should contain those changes. Looks great. Okay. All right, any questions surrounding Git desktop in specific, or whatever we just went over? So the merge process, creating commit messages, all that stuff. Yeah.
I have two questions. One is about merges. Merges happen exclusively on the website. There's no like shortcut in the desktop.
I don't think so. Actually, there was. So you could, it says to create pull request right over here, but what I assume it does is it takes you to the website.
When you merge,
Yeah.
You can merge. Click on the.
Was it in repo?
Nope, not that one. Yeah, click on that, and then there's at the bottom there's a call merge. So you're able to choose to merge with whatever. It's a better way to do it because you can visualize it.
Okay.
Ah, I should know that. So wait, if we do this,
Yep. And then like you want to merge to that.
yeah. Oh, it's hard. We're gonna do bad practice here and do main just for that. Okay.
I think because everything's already up to date, so there's
Yeah. It's made changes I made. That's another way to do it, I guess.
The second question I had was like kind of about visualization. Like early on in the beginning, you got like the diagram showing like what branches were and like how things like break off and go further down away from main.
Yeah.
Is there something like that that we can see on Github?
I think so.
Extension is called Git Lens. That's
Yeah.
you visualize it.
So it should be in that Git extension pack that I was talking about earlier. If not, you can just look up Git
Or
lens.
Git Kraken. There's a Git Kraken as well. That's also pretty good.
It doesn't appear weird. But yeah, Git lens would look something like this though.
I think it's Git Kraken.
Pretty sure Git lens also does it. So that's kind of what it would look like on Git lens.
Okay.
So
It's Git Graph, I'm sorry.
Git Graph.
has a pretty good visualization as well.
Git graph.
Git Graph, yeah.
What's
Yeah,
that?
it's a part of VS Code extension.
I believe there's a command for it that also shows it on your terminal, right?
It is.
I don't know what the name of it is. I never use it.
I have like the pictures in the terminal.
No, so it would be in the terminal. You only could like use characters and ASCII, so it would represent it in that way.
So this looks like
Yeah, I mean, yeah. If you tell me the command, I can do it right now. I don't. No, it's not gonna be that. That's like
Git log dash dash all dash dash decorate dash dash online dash dash
pretty long
no
command.
space between.
Sure says online. Okay, so there we go. So yeah, doesn't look the best, honestly. Honestly, I can get used to this though. That's up to you. If you're more visual, obviously go for the Git lens option. Okay, so
Thank you guys.
of course. Okay, so this is alright. Okay, so that was the kind of training wheels version. Once again, if you have someone in the hackathon, like at the start, who doesn't know how to use Git, you should probably teach them GitHub desktop instead, because it's very easy. Like we went over it in 20 minutes. Here's actual Git, which is what I recommend you all use. This is like off the training wheels actual Git. So first of all, obviously install this already if you haven't. Git extension pack on VS Code. What's neat about it though is I'm going to go over things for VS Code that make it easier, but you can do this all in the terminal itself. I'll be showing y'all how to use that like through commands. So that's it. So we're gonna basically do what I just did, except we're going to use the terminal instead. So let me just clean this up. It's okay. Let's see what I should do. And I can do folder. That works. So just select a new file for it in VS Code. If I have in the file, open folder, you can make whatever. Okay, so to clone in your terminal, what you're going to do is you're going to type git clone, right? And then you're going to just type the URL, right? So I'm just going to get the URL from earlier. Should be this. And then voila, it'll just paste it right over here. And now it's configured. So what it does is it does two things. It copy and pastes it and also runs another command known as git init. Git init essentially initializes your Git repository into your local repo, right? So it gives us all these cool features of being able to see our branch, being able to make commits, view our staging area and all that. So we have this right here. So that's a way you can view branches in here. But you can also type git branch in the terminal. And it will, okay, yeah, so you gotta change directories into the one you just made through cd, that. I think I did the wrong one. It looks like it. I guess that's fine. Yeah. Okay. Once again, raise your hand if you're having issues, but I essentially just cloned a repository that I was showing you earlier, and now we have a copy of it. Okay, so you can pull from Git using the pull command. So it's just git pull, and usually you could add origin before it. We're not going to go into much detail on how that stuff works, but by default, it should have everything pulled. So, I mean, I always, just to be safe, like to type it. Obviously. Yeah, so we're already up to date. It means we have everything from the repo in our current one. So that's good. Okay, when it comes to changing branches, you could either use the GUI like so, or you could use a command known as git checkout, and then you list it. So in our case, we do not have, what do we do? We're going to check out into dev, right? But if you don't have dev created yet, you're going to want to create it using git branch and then dev. So if you run that command, it'll essentially create a dev branch, and the source will be the current branch you're in. So it's going to create a dev branch from main. So you're going to do that first. Obviously, I already have it, so I'm not going to do it. And then you're going to switch branches. So to switch branches through the terminal, you type git checkout, and then the name of it. And so, as you can see, it automatically applied those changes I made, so now you have modulus. That's great. Okay. I'm going to create a new branch. We're going to add the power operation now, so let's do that real quick. So I'm going to make a branch known as power. Then we're going to change that branch. Okay. So now we just add our whatever changes we want. So I'm going to do that real quick right over here. Very simple. Then right over here. Okay, looks good. So once again, just add whatever changes you want. It doesn't even have to be something that makes the code compile or makes sense. It could just be like a comment saying whatever. That doesn't matter. So there's a few ways we could check our staging area. The first way is through this right over here. So if you have the extension pack, you should see source control. Source control essentially lists off all of the changes you made as well as your staging area. So remember, the changes you make on your local repository and the staging area are two separate things, right? So I think I actually could show it like that. That's the best way to show it. So it's like this. So essentially the staging area, just going over it again, it's a temporary area where the changes you make on your local repo are essentially stored at before you save them through the commit, right? So to add it through the terminal, you use the add command, right? So you can do git add and then the name of the file you want to add to your staging area or the folder. Usually most of the time I'm going to add everything at once, and that's what this command right over here is for. So the git add, then you use dot for it. So if I just type this, I have to do that again. There we go. So it's going to save all of our changes into the staging area. So as you can see over here on the right, it's no longer in the changes staging area. That's great. And you're ready to commit through a message. On the terminal, I think you would see it with git status. That showcases everything. So this is our staging area right over here. All of these are additions made or changes made. And then next thing we would do is we would create a commit. So in order to commit, you run the command git commits. And you have to provide a message, so that's where you're going to provide this right over here. So -m for the flag message, and then you add whatever, right? You would want to follow conventional commits. That's how you do it on the terminal. You can also, it's a lot easier to just do it over here instead, though, if you have the S code. So you add whatever. We commit that. Great. We're just going to publish our branch 2. Okay. So then once again, the last step after you commit, once again, if y'all remember, is that you still need to upload it online. So we're going to do that through push. So git push should do the job if you just made your commit. In our case, it did. Actually didn't. That doesn't work. Just try origin, because I think that's what we push into. That's not good. Oh yeah, we don't need a push because earlier when I published the branch, it actually did the push for it. That essentially was the push. That makes sense. Yeah. Okay. Usually though, the push will like tell you some progress on what's being uploaded and such. So we got it right over here. That's great. So you could do git merge through like a command. So you could do git merge dev, and it just, I think it just like raw dogs it. It does it automatically. But once again, you want to do a PR for safety. And we should be good. keep redirecting me. Okay. Yeah, so that should look good. Yep. Honestly, I had a lot of step-by-step instructions here because I also kind of want this to be a guide towards the people in the hackathon. So I will state once again, if your teammates do not know how to use GitHub, you could just give them the slides and it kind of goes over what they need to know for GitHub Desktop and for Git if that's what they want to use. Overall tip though, once you start using the terminal for Git commands is to have a cheat sheet on your side. So just have it open on one monitor. If you're not crazy and you have like 4 monitors, probably just a tab. But it's a great way to have a cheat sheet out as you work through Git.
I think I sent a pretty good one.
Really? Let's check it out. Yeah, it's always a great way to learn commands when you're using them. Obviously, as you use it, you memorize it. So that's pretty great. So this also isn't too bad. But you have to know the definitions for each, and you might have to click on it. So if you want a PDF version, that's it. Okay, so before we start going into other Git commands, I want to quickly go over what a merge conflict is and how you could solve it. So once again, I think for the scope of a hackathon or a class project, the worst thing you'll have to deal with for Git is what's known as a merge conflict. And to put it in very simple terms, a merge conflict occurs when 2 developers are making changes from one file at the same time, right? And then eventually when they both have to merge, that kind of creates a conflict where it's like, hey, do I use this developer's version of the code or do I use the other developer's, right? And a lot of the times that requires you to manually look over and decide which change to implement, right? So Git makes it easy to handle most of the time, but obviously there's multiple ways to handle them, and you want to avoid them as much as possible, which is why I was giving out advice like make sure 2 developers aren't working on the exact same thing at the same time, as well as make sure you're not doing too many things at one time in a branch just to prevent these from happening, because doing it manually takes some time up. Yeah? Out of scale. So I'm going to try and simulate a merge conflict. So you don't need to follow along for this portion. It's fine. We'll just have it be both from dev probably. Okay. Let me see what I can do here. I guess we'll just change it. Should be good.
Was that like chart you made in the terminal for Git? Was that like a command?
Yes,
Do you remember the command?
It should be in my history.
it's git log something.
I might have it in memory. That's unfortunate. It's the only command I can't see in history. Okay, I'm gonna go off of memory. It was git log dash dash. It wasn't diff. All right, we're looking it up again, I guess.
Wait, it's dash dash graph.
Okay, dash dash graph, and then I think
Git log dash dash all dash dash graph.
okay all. So yeah, I think just doing git dash dash all dash dash graph should work. Git log. It's gonna mess up the thing, but I don't care too much about that. Try to merge dev A into dev. How's it say? I think I should have it now, if I can find it. Okay, it's 7:20. How about we do this? I'm gonna set up a merge conflict, and in the meanwhile, we could actually have our second round of blue kit. That sounds like not a bad idea. Work. Okay, so this one will contain some questions that we briefly went over on this. It might contain a few things that we didn't go over, so test a bit on that, get knowledge. So. How about the good stuff like? What did I do earlier to create a merge conflict? I think I just changed. I made two commit. I made two. That's him.
It's in the same file. Change one thing. So you have two branches starting from the same code.
Yeah.
In one branch, make a change in one file, and in the second branch, make a change in the same file. And the overriding like know like the same location.
Got it. Appreciate it.
So I changed like the same line.
Yeah.
Not me.
Lily.
Oh, I know what to do. Very easy. Okay. Where's the little dash? Also, for those of y'all joined in between, the first, second, and third places will be able to win Debug Rubber Ducky. You're handling the blue tip. For other. I hate this one. Action?
Yeah. You don't create a branch and pull. How do you pull from a branch that doesn't exist until you create it?
Theoretically, that would work in the term with a command, I think. Were all the other answers incorrect? Because that would still be kind of incorrect in theory, but it would be the most correct. You know what I mean? Did you name yourself? What did you name yourself? Because I think you were once name yourself that, right? Check and record. Pretty good.
Yeah. Maybe invest in that.
One of them is me, one of them isn't me.
Might have been the same imposter who made themselves Quentin in the web dev workshop. It was actually me, which is kind of confusing because now someone else is doing it. I'm sorry, bro. I just outed myself. So wait, if I'm like first place, do I get the? I guess I do. I get the debug. That's pretty neat. 80 seconds. Yeah. Smiling for the next 5 minutes, bro. You gotta take advantage. I don't care what you do. Are you gonna be here on Sunday?
At church, it's about like 1.
That works, yeah. 'Cause we just need you for before the opening ceremony or closing ceremony, which I think is like, I think 2 to 3 p.m. is where you want to show up.
Where's it at?
It'd be at PFD.
I don't know, like,
Oh, sorry. Dude, the other 2 photographers aren't going to be there on Sunday.
oh, they're Saturday.
I think they wanted to take group photos on Saturday and Sunday. The Sunday you obviously want it because the t-shirts
Why
are
not?
there.
Friday. When everybody's there, like the opening ceremony, the closing ceremony. Yeah, I feel like that was
Maybe, I don't know if it's good for practice. Some people might ditch, but that doesn't.
It's like the opening
That's what
ceremony.
most people are.
Yeah. Most people usually ditch the last one. I was there.
When is it over? Jeez.
15 seconds.
It's gotta be Fortnite.
Keep that out. Merge conflict. Come on, bro, please. I need to win this.
My mom's kind of homeless.
I don't care. Let's go.
No! You're so close.
I know. It's totally fine.
Who's nice, dude?
Who is nice?
Who's nice, dude?
Let's just be very humble. I know, guys. It was me all along.
Please come up and take your prize. Thank you, guys.
This guy.
Thank you.
This guy.
Thank you.
You're great!
Thank you.
I know. I was second place. I'm so nonchalant. All right, and who's Olivia?
I'm very happy.
The 2 people who ended up making the slides are first and second place. That's hilarious. What's it?
Yes, pick any dot.
Good catch.
Do you want to get first and second place?
Take him too. He won last.
Yeah, whoever won in the first game.
The first one. You were busy eating. Lame.
They're like kind of rock hard though. Dude, I can give
Come on, James.
Dude, if he throws some top, like, if he throws some top, it might be someone who can show. Like,
Sorry?
Second place didn't want third. Second.
Second is him.
I'm pretty sure that was Hudson.
Come on, Malik.
That's not allowed, bro. Hey, this is cheating.
Yo, give some more energy. If I get that. Yo, you're the president. Give some more energy, bro.
Alright, you guys see me do this on 3. 1, 2, 3.
GSC. It's something for me to tease Malik again.
Gina, can I please get a cookie?
Okay, go ahead.
We're supposed to give them away after the first one.
You got the broken one. No, I'm just kidding.
You gonna be in the hackathon?
Yeah, his teammate with Quinton.
Oh,
Yeah.
I got 20 on y'all, bro. Please don't lose.
We actually did it? Yeah.
I mean, hey, we're trying to keep the streak.
I mean, you guys gonna win without a Han. The one who sabotage everyone.
What are you talking about? See ya. Thank you guys.
Yeah. Yeah. What are you doing?
I'm changing it back to this. Okay, so this may happen if you have 2 branches from, let's just say you have 2 branches from one branch, right? So both have the same commit, and then you end up making changes on both of them to the same file. What will end up happening is when you merge one into the other, you'll get what's known as a merge conflict, and it'll look like this in the in GitHub, right? So when it comes to these, you have two options to resort the merge conflicts, right? The first of which is to handle it in your IDE or through the terminal itself. And what's neat about it is Git literally gives you instructions on how to do it. So sometimes you might not be given an option to reserve conflicts on like the actual website because it's just too many. In that case, you just follow these commands right over here, and then it makes it very easy, trust me. But in our case, for the sake of time, we're going to resolve it online here, and this is essentially what it'll look like, right? It will present you with this right over here, where in between these two lines is going to be your current change. So I believe this is what's currently on the branch, and then below it is the branch that you're merging into, right? So you can decide whether or not to keep what you currently have or whether or not you want whatever you merged in that branch to come in. So this is where you kind of have to manually look. In our case, we want to, let's keep what we're merging into this. So we're going to do that and then just mark it as resolved and you commit. And then we should be good. Yeah, so honestly, for a hackathon or small scale project, this is probably the issue I'll see that most of y'all probably having with Git. So obviously, if things get too complicated, if you can't handle the merges on VS Code or it's just like too much, that's where you can send out a mentor request, and then someone will help you out with that and just merge it. So I'm just going to wrap things up here with some other Git commands. We already talked about this, Git merge, and then you mentioned the branch. This, once again, it's not entirely recommended for larger projects because you would want to actually make a PR request, and then the PR request is looked at by the Git master. You could do Git status. Git status is how you view that staging area as well as a few other details about your branch. You got Git log. Now Git log lists out all of your previous commits for your branch, and what's neat about that is all of these highlighted in yellow are, I think, IDs assigned to each commit. And using those IDs, you can restore your branch to previous commits. So that's kind of how you could revert your changes. There's also a few other things it mentions, like whoever made it, as well as the date it was made on. And I think the comment or the description of the latest commit. So we also have Git stash. We didn't really get to talk about it much, but there might be situations where you have changes made in your staging area that you don't necessarily want to commit, but you also want to change branches, right? So because of that, you usually would have to delete whatever's in the staging area or commit it. Sometimes you don't want to do either. So that's where Git stash comes in. It just creates like a local, you can think of it as like a local pool for all those basically a local pool for all those staging area changes. And you can go into other branches and do that. Then once you come back, you can grab whatever from the stash, you continue work, right? And then, I don't know what I'm put there. So you can actually merge select files as well. So I kind of find myself doing this sometimes where you do not want to merge the whole branch. Instead, you want to merge just like a folder or a few files. So the simplest way, there's many ways you can do it. I think Rebase is one of them. But this right here is the easiest way to do it. You just do git checkout and then you mention the source branch. So that's wherever the branch you want to get the merge from is coming. So if we're in dev and we only want to merge like a single file from someplace else, we're just going to mention that other branch. And then you're going to mention the path to that one. So the path of the folder file, and then it'll just merge all of those changes onto there. Okay, any questions about the command line for Git? Okay, I think that's it, except it's not. Okay, we have about 20 minutes, that's enough. So I also wanted to reserve a portion of this towards open source contribution. So that is via GitHub, and essentially that's what most of what the software and devices you're using run on. It's all open source. Obviously open source is the best way to go because the more people who are looking at your code, the better it will be, speaking overall and overgeneralizing things, but that's a lot of text, Holy. I'm just gonna summarize it. So an open source project is essentially a library or framework that exists. So some y'all may have heard of some of them like TensorFlow, React, just to name a few that we all use and such. And a majority of that code base, as well as the changes made to it and all the patches, actually just come from newer or experienced developers who want to pitch in and make their own changes to it, right? And the thing is, most of these open source contributions will have their own GitHub repo, and they have a whole system for reading the rules around making contributions, and then actually making a request to like submit it to the main repo. Very similar to a pull request. So there's a few ways you can contribute. I listed them right over here. I'm actually going to start with documentation, as in this is something that's more beginner friendly. As in beginner friendly, I mean to the actual framework that it's on. So you just create or you can update documentation somewhere in the code base, or we kind of joked around say the README, but yeah, you could do it for some of the READMEs and some of the parts of the projects.
Basically, if you don't have significant changes, don't do it.
Essentially so, but I pitched this in for beginners to a framework because not only are you still getting contributing experience out there, which is valued, but you also kind of learn the parts of the framework that will help you do other ways of contributing later on. So it's a good learning opportunity as well. The next best way is through code contributions themselves. So this could be like writing new code for features or fixing existing bugs, which you would need a test for obviously, or just adding improvements or optimizations you know could apply to specific parts of the code, right? And it directly improves the functionality of it, which is always great. The next thing is known as testing, right? And this is another great feature that kind of sometimes overlooked, but you can ensure that their code is bug-free by running certain tests on parts of it, right? So this could be unit-based tests or integration testing, whichever. And by doing these, you can contribute either A, by reporting bugs, they value that. So if you don't know how to properly fix a bug, you can actually just report it, and that's totally fine. Yeah, so that's what the issues page is for on GitHub. Some of the open source contributions will have like the tabs on the top, one of which is issues. Good point out there. And I think actually for those of y'all in software, one of the courses, 4332, software quality and testing. Correct me if I'm wrong, but I think at one of the final assignments is to make a contribution to an open source project, or like make a test for an open source project, right? So it's a great way to get hands-on experience. And the last way, if you can't do any of these, the last resort would be to just provide some sort of like support surrounding it. So a really underlooked aspect of it, I would say, is creating tutorials for it. So obviously there's like the meme of like having a very obscure random issue, looking it up on YouTube, and then like you get like a savior guy from India who decides he had the exact same problem and gives you like a perfect solution to it. So those are some other ways of contributing. It doesn't need to be to the direct code base. It could be surrounding it. And then here are some of the benefits for it. Obviously, you get experience with the framework. So you might be wondering, what are some great ways I could showcase I know a certain framework or language without having experience with it at an internship? And although I could talk about a million reasons like projects and such, but in research, I think another great way to showcase it that you actually know the details surrounding a framework is by contributing to it. And obviously your contributions will show on your GitHub profile, so you want to share that in a resume or something, but it's a great thing. You can also network, so I do know a few people who did make contributions and got to know a few people who are also in that community. And that's usually a great opportunity to line up and ask them about certain job opportunities. And I guess clout's another thing, because the Google Experts program is literally about people who are cracked at certain frameworks, and usually that requires you to have a lot of experience with frameworks and such. If we have enough time, I was thinking about just doing a practice contribution where you can test out on this repo and then you do all that, but honestly, I don't think we have enough time for that. And then here's some like just basic ideas for contributions that I personally have made. The rest I kind of just looked up. And once again, this is for your future reference, but I think, yeah, it's open source contributions is a great way to go if you don't have any prior experience. That's it.